Okay, question 9, part 1. Write as a power of 3. 243, good God. Okay, well, I suppose I'll just hit my calculator and I'll just start putting in numbers. So I'm going to put in 3 to the power of 10. Well, that's way too big. That's 59,000. So now I'll put in 3 to the power of 5. 3 to the power of 5. And I get 243. Wow, second time lucky. And that is simply just trial and error on your calculator. Write root 27 as a power of 3. Well, the first thing we do is, I know that 27 can be written as 3 to the power of 3. So that's a square root. Now, a square root can also be written as the power of a half. So that's 3 to the power of 3, all to the power of a half. Now, when we have a situation where we have brackets and indices, we multiply. So that's 3 to the power of 3 over 2. Solve x, the equation 3 to the power of x equals 243 over root 27 to be squared. So what we're looking for, the x is up in the indices, so we have to make all our base numbers the same. I know that 243 is written as 3 to the power of 5. So I have 3 to the power of x equals 3 to the power of 5. Now, root 27. Root 27, we now know from part B, can be written as 3 to the power of 3 over 2. Oopsie-daisy, 3 to the power of 3 over 2. And all that is to be squared. Now remember, a square distributes across everything in the bracket. So when we have brackets and indices, it multiplies. So 2 times 5 is 10. But don't forget, it distributes across everything in there. So it's 3 to the power of 3 over 2. This is 3 to the power of 6 over 2. So that's 3 to the power of x equals 3 to the power of 10 over 3 to the power of 3. Now, this comes over to multiply because it's dividing. So I have 3 to the power of 3 multiplied by 3 to the power of x equals 3 to the power of 10. So in a situation where you have two base numbers multiplying, we add our powers. That's 3 to the power of 3 plus x equals 3 to the power of 10. Our base numbers are the same, so our indices must be the same. So 3 plus x must be equal to 10. So x is equal to 10 minus 3. X is equal to 7. All right, let's have a look at question 10. Remember, you can slow these videos down or speed them up using the icon at the bottom right of the YouTube video and changing your playback speed. So write 2 to the power of 6 minus 2 to the power of 5 in the form of 2 to the power of k, where k is a natural number. That means a positive whole number. If you're hearing screaming in the background, that is no one being tortured. That's just children playing with children. Now, so 2 to the power of 6 minus 2 to the power of 5 in the form of 2 to the power of k. So, I mean, if you wish, we have no explicit rule that we've mentioned for just simple subtraction. So there's nothing stopping you of going straight to the calculator and putting in that number. That's fine. And if you do 2 to the power of 6 minus 2 to the power of 5, you end up with the number, computer's all over the place today. You end up with the number 32. But we need it in terms of 2 to the power of k. So what can 32 be as 2 to the power of something? Well, let's just start banging in numbers into the calculator. Well, 2 squared is 4, and 2 cubed is 8. And 2 to the power of 4 is 16. 2 to the power of 5 is 32. Perfect. Now we've got to solve this equation. 2 to the power of 3x minus 4 equals 2 to the power of 6 minus 2 to the power of 5. What we're looking for, the x is up here in the indices. That means we need to make our base numbers the same, which they are here. But this is a little complicated. As I said, we don't have a rule for it. But using our calculator earlier, we were able to write that as 2 to the power of 5. So 2 to the power of 3x minus 4 equals 2 to the power of 5. Our base numbers are the same, so our indices must be the same. 3x minus 4 equals 5. So 3x is equal to 5 plus 4. 3x is equal to 9. And x is equal to 9 over 3. X is equal to 3.